All right, hey, all you cool cats and kittens out there. So today I wanted to kind of keep up with the ankle here. So I got most everyone's um, assignments and the rough drafts from last week, which for the most part seems to be pretty good so far. So I should have all that graded by today sometime. All right, a few things I wanted to do. So for Unit 6, you don't have a whole heck of a lot of stuff to do. But what you're going to do here is for your discussion question, you're going to pick one topic to respond to. So I have 3 topics here you can use. So just make sure you respond to at least one of these. And then obviously make sure you respond to somebody else's post for a follow-up. But why is the ankle most often injured in joint in sports, and what can be done to prevent ankle injuries? What can you do to ensure an athlete is ready to return to play after an ankle injury? And again, how do you prevent re-injury? And then if an athlete has plantar fasciitis, what would your treatment plan be for them and why? So pretty straightforward with them. So with the ankle, it is the most often injured joint in sports, and it's also the most often re-injured joint in sports. So that's one of the things we want to really focus on, is how to kind of prevent that from happening. And I should probably share my screen so you can actually see what I'm actually talking about. So there you go. All right, now as far as your lab stuff, so what I'm going to do is to change this here. So you'll have this to be able to turn in. Now, what you'll need to turn in for this, and this is incorrect here, I don't know why that was included. So what I want to see you be able to do is, obviously you need to fill out the movement analysis for the ankle. For your range of motion assessments, what I want you to see you be able to do is to tell me what muscles cause the action of each movement. So you're not going to have all of the different measurements and whatnot. And if you don't have all of the positioning of the goniometer for all these, that's fine. I'll go over those with you. We'll probably do that on Thursday, or well, I guess Wednesday. But you don't have to have that. What I want you to have is, for every movement that you have, I want you to at least fill out the muscles that cause that movement. And then in terms of the manual muscle tests, all I want you to tell me to do, or tell me, is how to do them. So that's what you'll need to do. And then you won't have to do the navicular drop test for this, but that is something we'll be talking about on your actual assignment here. So again, for your lab, what you'll need to turn in is you need to complete the movement analysis, which pretty simple there. For all of the ranges of motion, you just need to take whatever that movement is and tell me the muscles that cause that movement. And then for the manual muscle tests, all you just have to do is tell me how to perform these tests. So pretty simple for that.
When you say perform the test, do we fill out each thing or like do our own explanation?
Yes, you just do your own explanation for it.
Okay, thank you.
Yeah, so you don't need to actually, like, I guess, like, do the test yourself, but you just need to tell me how you would do it.
Okay.
And then for your assignment here, for this, you just have these 5 questions. So navicular drop, you'll do on that. So what's navicular drop? We'll talk about that a little bit today, but I'll really show you what that is on Wednesday here. And then people that have a really big navicular drop, what would you do for them? Describe the movements of the ankle joints during pronation and supination. This one here, go on your toes 20 times with straight knees versus your knees bent. What's it more difficult and why? This will actually also answer the manual muscle test for your gastrocs and soleus. And for this here, I'm giving you all of your agonist muscles, and you have to tell me what the antagonist is to them. So you also have to tell me what muscles will oppose the primary movement of these muscles here. So that's that in terms of your assignments there. Now, what I wanted to just go over today here again was really the muscle anatomy and then the actual movements that are. So you have a lot of soft tissue that goes into your lower leg and foot. And I want you just to kind of focus on really the more major types of muscles. So not really worrying about things like, say, your like intrinsic muscles. These are important. Like, I mean, they're definitely worthwhile to know. If you wanted to go into, like, say, podiatric medicine, or you wanted to be like a podiatrist, yeah, you absolutely have to know all these. But for us, they don't really perform all that much functional movement for us. A lot of these are going to really impact, say, like the overall health of your like foot itself. But in terms of actual foot movement, they do primarily a lot of stabilization, but that's really kind of about it. They don't have a whole lot of a major role for us. So I don't want you to worry about the intrinsic muscles. What I do want you to worry about is from this here, so gastroc soleus, fibularis, your extensor and flexor digitorum muscles, tibialis anterior and posterior, and your hallucis muscles. So those are the set of 1, 2, 3, 4, 5, 6 slides you should be remembering in terms of the actual muscles acting on the foot and ankle. Now, you have 4 primary movements for the foot and ankle that you should know. So there are your 4 main movements you have with the foot and ankle there. Plantar flexion, dorsiflexion, eversion, inversion. If I were to take a foot, and let's say that this is my right foot here, eversion would mean that I move this foot out to the right side of it. So I would be kicking my foot out away from me. Inversion, so that's eversion. Inversion would mean that I pull my foot in towards me. So kind of like I was rolling my ankle. Plantar flexion means that I go down on my toes. So my toes will touch the ground, my heel will be off the ground. And dorsiflexion means my toes come off the ground and my heel stays on the ground. In terms of the muscles that do that, so first off here, we have our calf muscles. So your gastrocs and soleus are your two major muscles that are going to do plantar flexion for you. Gastrocs is the biggest one, and that's the most superficial one. Because gastrocs originates on the femur, it also does knee flexion. So it has knee flexion because it crosses over the knee. Its primary function, though, is plantar flexion. Soleus originates on your fibula, and both of these insert on your calcaneus to form your calcaneal tendon. So that there, which you probably know by your Achilles tendon. But both of these serve in the function of plantar flexion. Here we go. Now this is showing the actual manual muscle test for this. But if you're doing plantar flexion here, there is your movement. So plantar flexion, you notice that toes are on the ground, heel is in the air. And then you can very clearly see how that calf muscle is firing there. So like we'll see on Wednesday, when you actually do the manual muscle test for your gastrocs and soleus, you actually do it in this fashion where you actually have someone stand up and do toe raises, or I guess you would say heel raises. So again, there is your plantar flexion, going straight up on your toes, heel goes in the air. Now, what he's doing here is he's showing how to differentiate between gastrocs and soleus. If you notice in this first picture, or the first movement here, his knee is locked out there. So obviously this one's bent, but he's had that in the air, so that doesn't matter. So don't worry about his right leg. But his left leg has his knee locked out. The whole reason why you do that is to make sure that you have your gastrocs moving. Your gastrocs is only going to move if your knee is straight. If your knee is bent at all, so if your knee goes, it takes out plantar flexion from gastrocs. So it'll still work, but it doesn't actually fire its main muscle belly if the knee is flexed. Now, when we get to soleus, you see how he has his knee bent, or his knee is flexed here. The whole reason why that's bent, again, is to make sure that gastrocs kind of goes away. So you can still see how there's some tension up here, and that's what you're going to get out of gastrocs when your knee's bent. But that is done to actually bend the knee. So your gastrocnemius still is going to contract when you bend the knee, but only the upper portion of it contracts. And that's the portion that really only works for doing knee flexion. The bottom, really 2/3 of gastrocs, is what you're going to use when you're actually doing, say, like your heel raises. But when you bend the knee, it takes that out. So now you only have soleus to work with. So legs straight, you're using primary gastrocs. Knees bent, you use soleus. But still, both do the same thing, which is your plantar flexion. Now, moving on here to some of your named muscles, and by named, I mean named after the bones that they go with. Anything that says fibularis, and you may see this also use the term peroneus. Peroneus and fibularis are the same thing. Anything that goes with the fibula is going to go to the outside of your leg. So all of these are on the pinky side toe. And all of these are going to move your foot or ankle away from your body, or away from midline is probably a better way to say it. So fibularis goes away or laterally. Now, both your fibularis, like the whole fibularis group, is going to do a little bit of assistance with plantar flexion. So it'll assist a little bit with that. But its primary movement is foot eversion. Okay, so eversion here. See, she's starting out with a neutral foot, and then eversion, pulling that foot out away from you. So there's your neutral foot, there's your everted foot. So a very subtle movement there. So if you guys just take your foot and try to move it out to the side, you notice that there's not much movement at all there. But that's what you get out of fibularis, that movement there from here to here. That's what fibularis does. So it just kind of further goes to show you that the fibula really doesn't do much of anything for us. It's just kind of there. But all your fibularis muscles do that exact same thing. They all help you go into eversion. So bringing that foot away from midline. Now, tibialis does two things. Tibialis anterior, tibialis posterior. Both of these are obviously on your tibia because they're named tibialis. So the function they both share is foot inversion. Both of those are going to help you to invert your foot. The main difference is where they actually insert on each other or insert on the foot, because tib posterior is going to help you with plantar flexion, whereas tib anterior is going to be your primary dorsiflexor. So tib anterior inserts on the side of your foot, kind of the top side of it. And this is so that it'll help pull your foot up. Tib posterior inserts on the bottom of your foot, so it helps to pull your foot down. So we've already seen plantar flexion. When you do inversion here, there is your inversion. So you do see how much more you get movement for inversion than you do eversion. So again, normal or neutral foot, inverted foot there. So quite a bit there. But that here, this whole movement here, tib anterior. If I go back to my everted foot, whoops, sorry. Fibularis is going to do that. So again, foot inversion comes inside or towards midline, so it's coming this way, and that's tib anterior. Foot eversion goes out, and that's going to be fibularis. Now, the other movement that tib anterior does is dorsiflexion. So dorsiflexion there we go, just like that. So I know I told you that dorsiflexion is where you bring your toes off the ground and keep your heel on the ground, and that's really the practical movement of it. But the true definition of what dorsiflexion versus plantar flexion is that dorsiflexion is going to decrease the angle made from the foot and the lower leg. So if he's standing straight up, for all intents and purposes here, this is a 90-degree angle. So that would be neutral. For everything that's less than 90, that is dorsiflexion. For everything, plantar flexion. So that's your actual clinical definition of what plantar flexion versus dorsiflexion is that dorsiflexion is an angle made from the lower leg and the foot of less than 90 degrees. Plantar flexion is an angle that is greater than 90 degrees. So if we go back and watch him go back into dorsiflexion here, you notice that this angle is now shorter than 90 degrees. So that's why he's in dorsiflexion. If he were just standing straight up and then he were to lift his toes off the ground, that would do the exact same thing as what he's doing here. So dorsiflexion, when he's doing this, the primary mover is tib anterior. So those are all of your primary movers for your ankle there. So really just these first four are what moves all of your ankle. So gastroc and soleus do plantar flexion. Fibularis does foot eversion. Tib anterior does inversion, and dorsiflexion. Tib posterior does inversion. And that's all the movements you have for your ankle. Now, last two muscle groups here are acting on your toes. So just like we had with the wrist and hand, anything that says digitorum on it refers to your toes. And specifically, it refers to your latter four toes. So that's your index toe all the way to your pinky toe. Remember that your toes, just like your fingers, are numbered. So number 1 is your big toe. Number 5 is your pinky toe. Anything that says digitorum moves toes 2 to 5. So index to pinky. What doesn't the digitorum move?
Is it the index, the big toe?
The big toe, yes. So the big toe does not do anything with the digitorum muscle. Only your second through fifth toe. So index toe to your pinky toe, those are the ones that are moving from a digitorum muscle. And it just tells you exactly what it does. Extensor versus flexor. Extensor is going to raise your toes. So toes up, flexor, toes down. So if my foot is flat on the ground and I use my extensor muscles, I'm pulling my toes up into the air. If my foot is flat on the ground and I use my flexor muscles, I'm curling my toes. So real simple for that. And then with the wrist, remember that we had pollicis meant the thumb. Hallucis or hallicus means your big toe. And again, does the exact same things as the digitorum muscles. So extensor hallicus and flexor hallicus, all they do is raise the big toe or curl the big toe. Now, yeah, they do a little bit with, say, like dorsiflexion, plantar flexion, foot inversion. Don't worry about that. That's a very, very nuanced movement, and it's really just because it's just like the positioning of their origination point. The main thing you want to remember is that your hallicus muscles are going to either extend the big toe or they're going to flex the big toe. That's the big thing. The insertion point on all these muscles should be pretty self-explanatory. If this is moving the big toe, the muscle has to insert on the big toe. Same thing for the digitorum muscles. because this moves your second through fifth toes, it has to insert on your second through fifth toes. It can't move them unless it inserts on them. So that's the main key points I wanted to kind of drive home today, was again just pairing up the actual motions of the foot and ankle to what's actually moving them, or the muscles moving them. On Wednesday, we're going to go over the actual movements in how we're going to measure them in terms of like what you would need for, say, like your lab-based stuff or your lab-based measurements. And then I'll also go over, again, this whole pronation versus supination bit, because that's going to be kind of important. That's going to help explain all this here. So we will explain that, and then I'll also explain that. By now, you should definitely know the difference, or how to answer number 4 for your homework here. And then, like I said, we'll cover this on Wednesday, and then we'll also cover all of the range of motion manual muscle test movements. All right, so if you guys have any more questions, I will stick around till you all leave. If not, I will see you guys all on Wednesday, hopefully.